Now, let's try to figure out if Bob would have earned more interest or less interest had he deposited all of his money at one time at the start of the 5 years. Meaning, if it was just a regular compound interest account. So let's figure this out. This means that he would have invested $5,000 for, what did I say, 5 years at the interest rate of 9%. So A equals P 1 plus I to the exponent n. It's 5,000, 1 plus 0.09 to the power of 5. And you should get $7,693.12. So as you can see, he would have earned a lot more interest if we take I equals A minus P, $7,693.12 minus $5,000. So he would have earned $2,693.12, and that gives us a difference of 984.71 from part A. That gives us a difference of $1,708.41 more in interest by investing the $5,000 all at once. So definitely, if Bob had the money, had the $5,000 to invest at the beginning of that 5 years, he would have earned a lot more interest than investing in the ordinary annuity. But I'm asking you to think about the practical reason, and I sort of just gave it away already, for investing money in a sequence of payments. Sorry, there should not be an either, my apologies, instead of in a lump sum. And the most practical reason is that you just don't have all of that money at the time. So I'm going to write that down. So in this case, maybe Bob doesn't have the $5,000 yet, and instead he has $1,000 saved up, and he knows that he can save up another $1,000 every year. Then at least by investing the $1,000 every year, he can still earn some interest. Okay, so I wrote down can still earn some interest by investing a smaller amount regularly. Last question on this page. How do you know when a scenario requires you to use the accumulated amount of an annuity formula rather than the regular compound interest formula? So how do you know when you're supposed to use this lovely, slightly complicated looking formula versus the regular compound interest formula? And the main word in a problem that's going to give it away is if you see every. Okay, every 10 years, or sorry, every year, every month, every week, every day you invest something. Okay, so that's really the key word for how you know you have an annuity. Okay, whereas this formula is used for one-time investments. You put some amount of money in once, and then you wait a long period of time, and then you get that money back. Okay. In particular, you want to look for at the end of every, okay, maybe the word each, so each month you deposit. If you see the word regular, and sometimes you might see the word payment, okay, a payment of $5 every day, for example.